Welcome to the session 5A on machine learning. Let me introduce you to the session chair, Dr. Kasun Gunawardana. He is a senior lecturer at University of Colombo School of Computing. He completed his Doctor of Philosophy at Monash University, Australia. His research interests are machine learning and information security. Dr. Gunawardana, I invite you to lead the session.
Okay, cool. Thank you very much. And can you all hear me?
Yes, sir.
Okay. So this is the final session, I guess, in this conference. And there will be another parallel session going on in another Microsoft Teams session. In this session, we will be having 4 papers related to machine learning domain. And I can see that there are so many familiar faces in this Microsoft Teams session for machine learning session. That is Dr. Mahesan, Dr. Badi. There are a few other very familiar faces as well. So without taking much time, let's go to the first paper. And the first paper is paper ID 104. Business Intelligence Assistant for Human Resource Management for IT companies. So there are 6 authors in that paper, and today the paper is presented by Kavishka Dabare. Kavishka is a 4th-year student at SLIIT, Sri Lanka Institute for Information Technology, and he's currently reading for BSc Information Technology degree, and currently working as a trainee software developer at IFS R&D International. So let me invite Avishka to start his presentation. Kavishka, sorry.
Hello. Yes, the video recording will be played, right? Business Intelligence Assistant on Human Resource Management for IT companies. This is our team. The agenda is as follows. First, I will explain the background, then the problem. Next, I will explain the solution. After that, it will be the research objectives. Then I will explain the individual components separately. Finally, I will give you the conclusion. The advancement in technology is exponential. Moore's law supports this by stating that the computing power doubles every 2 years.
I think we can't hear the voice of Kavishka. So shall we start from the beginning?
Sorry about that, sir. I'll play again.
Yeah, that's great. Yeah.
Good evening, ladies and gentlemen. I'm Kavish Kadaber from Sri Lanka Institute of Information Technology, and I will be presenting a research on business intelligence assistant on human resource management for IT companies. This is our team. The agenda is as follows. First, I will explain the background, then the problem. Next, I will explain the solution. After that, it will be the research objectives. Then I will explain the individual components. Finally, I will give you the conclusion. The advancement in technology is exponential. Moore's law supports this by stating that the computing power doubles every 2 years. In such a premise, many IT companies have risen to meet the ever-growing demand. Human resource is considered the most important asset in any organization. IT companies strive to acquire and retain such talent. However, many organizations, especially in the IT sector, lack the resources to devote to human resources. This is because they focus on their product during the early stages, which in turn reduces focus on employee management. The statistic which says that 20% of small businesses fail in the first year, while 50% fail in their fifth year and 70% after a decade confirms it. Our solution will look into methods of simplifying and assisting human resource processes without losing the human component or human interaction necessary to facilitate these processes. The objectives of this research are to streamline the resume analysis process, provide a reliable ranking solution, allow the user to create an employee engagement survey and quantify the qualitative comments, as well as to identify specific processes used in the IT industry and demonstrate them as suggestions to the management. This is our system diagram of the solution. The first component is the Smart Resume Analyzer. Acquiring great talent starts with a well-structured resume. In a day and age where there are more IT companies and educational institutes which offer more IT courses, the IT workforce has increased exponentially. This results in more resumes per hire for IT companies. The main aim of this component is to scan resumes, extract the information, and generate a scorecard according to user specifications. For the extraction of information, the FITS library is used. The data is extracted as a raw text. A recurring neural network model is then trained using 55 resumes to identify various segments of information such as demography, education, experience, and skills. This is segmented using character pointers. The extracted information is then subject to scoring, and the scoring mechanism is customizable. The user can input the scores they need to give to certain criteria from the client interface. Another feature of this component is that after the initial shortlisting, which will be done in the next component, the aptitude test scores as well as the soft skills for the interviews will be appended to the scorecard as well. The soft skills will be gauged by a form which is given to the interviewer to fill out about how the interviewee has done on the interview. When looking at the results of the Smart Resume Analyzer, the implementation of the FITS library has an accuracy of 87%, and the implementation of the SPACY library has an accuracy of 83%. The RNN model has a trading accuracy of 60% and a testing accuracy or validation accuracy of 77%, which means it can identify newer data well. The next component is the Smart Candidate Ranker. Manual screening of resumes is the most time-consuming part of recruitment. Up to 88% of resumes received for a role are considered unqualified. Therefore, a recruiter spends on average 23 hours screening resumes for a single hire. The main objective of this component is to reduce the screening time by increasing the performance of this process. The initial inputs for this component are the scorecards generated from the Smart Resume Analyzer, as well as the minimum acceptance criteria which can be given by the user. Then, two separate lists of candidates are compiled. One is the non-mandatory list, which selects applicants from the keywords given in the minimum acceptance criteria, as well as demographic factors such as gender and age, if specified. The other list is a mandatory list which selects applicants based on the educational qualifications and their specialization. The mandatory list uses a Levenstein distancing algorithm, which is a natural language processing algorithm, which is used to match string patterns approximately. This can be used to identify misspelled words as well. The applicant's comment to both these lists, the mandatory and non-mandatory lists, will be then considered as the initial shortlist. The accuracy of the initial shortlisting process is recorded as 92.85%. Once the aptitude test scores and interview evaluations are pended, the user can use any of these three algorithms to generate a ranked list of candidates. The first algorithm calculates the cumulative total. The second algorithm calculates a weighted score. The weightages for the different criteria, which can be education, experience, and skills, can be defined by the user. The final algorithm is an average score distribution algorithm. The reason we give a ranked list of candidates is as the final decision on which applicant is applicable for the job post should be decided by the management, as there are factors such as cultural fit, cultural fit, and teamwork which must be assessed as well. Since this component is focused on increasing performance, all of the infrastructure is deployed in a serverless environment. An internal database is also used to cache as well as increase the speed of information retrieval necessary to run the Lambda functions. The next component is the Employee Engagement Survey Generator. Employee engagement is a crucial segment in human resource management. This is because employee engagement promotes employee motivation. A motivated employee is more productive, while a demotivated employee can be detrimental. Many companies use surveys to collect information, but surveys offered are rarely customizable. Furthermore, studies show that comments which in surveys are usually optional. Some surveys don't have comments at all. This can be stated as a problem because these comments have a lot of important information, especially when considering that employee engagement is a qualitative factor. There are two main objectives to this component. The first is to allow the user to create a customizable employee engagement survey according to the key drivers specified by the user. Our front end facilitates in creation, deployment, as well as collecting the data. The collected data will be then showed to the user in a dashboard. The second objective of this component is to find a way to quantify the qualitative data in comments. This will make it easier for the management to understand what the level of the key driver as well as to save time. The methodology behind this is as follows. An initial questionnaire was distributed among IT employees to gather information on what kinds of comments are given in an employee engagement survey. The data, which was received from by 98 respondents, were then used to train a long short-term memory recurrent neural network. This model was used to obtain a value from 1 to 5 depending on the type of comment, where 1 denoted a very negative comment, 3 denoted a neutral comment, and 5 denoted a very positive comment. Another approach also researched by the use of a natural language processing algorithm. The purpose of this algorithm was to create a lookup table per key driver, which had a value for every word. This algorithm was developed using many NLP techniques such as word substitution and parts of speech tagging or post tagging. The main outcome of this component can be showed as a comparison between the LSTM model and the NLP algorithm. The model had a training accuracy of 84.66% and a validation accuracy of 71.21%. This meant that the model found it difficult to process newer data. On the other hand, the NLP algorithm showed a consistent accuracy of 86.48%. However, there have been instances where the generated output is an outlier compared to the expected output. This table shows a few examples of the usage of the NLP algorithm. The final component is the business intelligence processor. There are specific processors unique to or mostly used in the IT industry. These processors are usually overlooked by HRM systems. This component looks into assisting in such processes. We all know how valuable data is to any organization. The flow of information within an organization is critical to the success of that organization. As such, this component will also have a dashboard which will bring together the information from the other components and display it to the management, which will help in human resource-based decision making. This component consists of three subcomponents. The first is the project team allocator. The purpose of this component is to suggest a set of employees for a certain project, as well as the estimated time for it. When an SRS document is provided, the SPACY and NLTK libraries are used to extract information from the SRS document. These requirements are then categorized into four categories, namely common, average, critical, and R&D. The estimated time per requirement is then calculated. For this purpose, a questionnaire was distributed among software developers to gather information on how long they take to complete a certain requirement. This information is then fed into a ML model, which will predict the estimated time for a requirement. The preferred technology should be given as well. After that, depending on the requirements, a team consisting of the necessary individuals will be suggested to the user. The next subcomponent is the technology update notifier. The skills of the employees are identified using our first component, the Smart Resume Analyzer. The GraphQL API is also used to identify libraries and the technologies, as well as the version used in our online repositories. Then, the Scrapy library is used to web crawl through the release pages of the identified libraries and technologies. If there is a newer version present than what is in use, a notification will be triggered to the user. The final subcomponent is the business intelligence dashboard. The accuracy of the time estimation in the project team allocator was recorded as 80%. This is because the time for an R&D level requirement could not be calculated definitely as it varies from project to project. The accuracy of the technology update notifier was 85.71%, as some libraries did not have release pages or the release pages were not directly identified.
In our users as disaster management authority and irrigation department basically. Inputs are weather factors such as rainfall, temperature, evaporation and water level. Here I want to point out a special factor before proceeding. When considering the input factors for water level prediction modeling and giving flood alerts, we identified several categories of input variables which can be used for river water level prediction modeling after clear study. They are geographical factors, hydrological factors, and weather factors. I have to especially mention that in this research, we have selected weather factors and consider the climate conditions and weather data only to do the water level prediction modeling. This is because due to the availability of data of the Adroy Basin, accuracy of data and doing water level prediction using weather factors give high accuracy for prediction according to our research and several other researchers worldwide. In this slide, you can see the basic structure of my system design. The input data are rainfall, temperature, evaporation, and water level of the upstream. The data pre-processing was done and they divided as training and validation data. The system implemented using LSTM and it predicts the water level of the downstream. LSTM is well suited in the current context due to the incompleteness of data, less computational cost, efficient computations, multivariate nature of variables, good memory with past instances, and low predictive time. The predicted output was subsequently divided into 4 classes to depict the intensity of water level which is likely to occur one of the flooding conditions. Those are no flood level, alert flood level, minor flood level, and major flood level. After that, predicted water level was fed into the ARIMA model and predict the estimated water levels for years ahead. This slide shows the available weather factors to detect the flood conditions. They are rainfall, temperature, evaporation, and water level. These are the information about my dataset. There are about 4,290 data in my datasets, and I consider this data from 2007 to 2016 and 2018. These are the stations which I taken into consideration in my research. Mainly, the rainfall stations are divided into 2 parts as upstreams and downstreams. You can see the list of rainfall stations in this slide. This slide shows you the names of the temperature and evaporation stations which are taken into the study. Upstream water level stations were Murakaswava and Ridhibendayala. Downstream water level station was Chilau. According to the existing data statistics from 1999 to 2008, the Dadruwa Reservoir is given respectively prediction analysis on the water level of the upper reaches run into reservoir downstream in the times of the normal river flow level, low flow level, and high flow level. With the purpose of reducing the factorial magnitude difference, we give a numerable value of standard factors in all levels, and alert warning gives when the water level is at 2.75 meters, and minor flood warning occurs when it reaches over than 3.75, and major flood causes when the water level increases above 4.2 meters. This research is carried out to analyze the potential of flooding in Dadruwa. Climate data is time series which can use various methods and recognize patterns from historical data for future flood predictions. The following are the factors which have been considered when selecting the LSTM model. They are choice of forecast, lead time versus time of concentrations, the robustness of approach, the computational time required, univariate time series analysis, multivariate time series analysis, and multi-step multivariate time series analysis. These are the regression modeling approach that we have studied. They are ARIMA and seasonal autoregressive moving average, smart linear perceptron model, and long short-term model recurrent neural network. Among those regression models, RNN long short-term memory network was selected to do my research due to the multivariate variables, and multivariate LSTM network is used here. The advantages of using LSTM networks are non-linearity abstraction and self-organization learning is very suitable for dealing with nonlinear and randomly data. However, there is a disadvantage of long training cycle. A more effective memory block will be designed in the future work. When selecting better optimization model, I have compared two models as adaptive moment estimation and the stochastic gradient descent. In this slide, you can see that adaptive moment estimation gives better results than the STT. Therefore, I have selected ADAM optimization model for my prediction model. Before proceeding the research with LSTM, several comparisons were done with other techniques. This slide shows you the results of MLP and LSTM. LSTM has high accuracy and R2 score level than MLP in time series analysis. You can see the final results taken from the LSTM water level model. The graph shows the water level predictions in 2018 as observed and estimated. The table shows actual observed water level and my estimated values. Results column gives the flood alert state according to the estimated value. These estimated values contain seasonality and trend due to its time series features. Therefore, seasonality and decomposing effects are to be removed before input into the model. This figure shows how the seasonality and trend were removed by decomposing them from the estimated values. To predict the estimated value for 300 days ahead, we can use it for to predict one or 2 year ahead. That's why I use here to hybrid ARIMA and LSTM together.
So why can't you model the whole thing with the ARIMA model?
No, because ARIMA can be used for only univariate data set. No, there is multivariate data. I have input multiple input variables. That's why I used LSTM here, there, and then hybrid ARIMA to estimate only the estimated output.
Agree. My question is not that. So, for example, you have a multivariate data. So in this particular case, how do you know whether those multiple variables do matter in your problem?
That means
like, okay, so you have a set of multivariate data, right? So univariate, you have one single variable, okay? So so in multiple cases, so let's assume you have 15 or 16. So how would you know whether all of these things is like affecting the final outcome of the problem?
No, I first I have selected all these input variables after doing a clear study. I have inputted
So
each
what
and
is
every
your
single.
finding on that clear study?
I have taken the weather factors only, climatic weather factors only. So according to the available data in the meteorology and the irrigation department, I have taken the consideration only for the rainfall, evaporation, temperature, and the water levels of each of these stations. And then I have taken my output estimated flood level or the water level of the chill out of the reservoir and taken that estimated outputs as the input for the ARIMA and then make the prediction for 300 days ahead. That's
So
what I
you
did
make
there.
the assumption that all the other variables, including the basin, would remain the same.
Yeah, the thing is that the difficulty of finding data by taking only the weather factors like temperature, evaporations, and because we have done a clear study that we considered and we found that there will be other factors, but they did not affect directly to the flood effect. But here we only consider weather factors, not taken as geographical factors, hydrological factors. Those are not considered here because of the availability of data of the reservoir. That's the reason.
Okay, so and also like what was the rationale of like comparing between a multi-layer perceptron and a LSTM?
LSTM can hold the memory. But MLP gives some kind of less accuracy than the LSTM, and there is a less efficient than the LSTM. Therefore, I made the comparison not only between MLP but also some other mathematical models also. And by after clear comparisons, I have selected LSTM to do this.
So why didn't you compare your result with the very basic form of RNN instead of LSTM?
Because there is a vanishing gradient in LRNN, some other difficulties and some
So
other.
does the vanishing gradient affect in this problem in this case?
Yeah.
Okay, thanks.
LSTM can predict more accuracy data than the models.
Okay, and there is another question from the audience. I can see that Prabhash is raising hand. Prabhash?
Hi everyone. I have one question. Perhaps you may remember around 10-15 years ago, there was a flooding that happened in Kalutara due to the Kaluganga. There was no rainfall, but there was a rainfall to Ratnapur area. So this happened in a few hours time. So I'm wondering, is it possible to combine your model with perhaps a sensor network, a wireless ad hoc sensor network or something like that, that real-time updates the system so that we can lively update the endangered people. Is it possible? What do you think about such an?
Here I have mentioned in my discussion part, there should be further improvement to make it as a real-time system by taking the weather APIs and other form of by including other forms of sensors in those areas and taking the real-time data, and after that we can make the predictions, because here also we have not only taken the rainfall in Chilau, we have considered the upper stream stations, rainfall stations to make this prediction, not the rainfall in the Chilau, low level area. But we have considered here also upper, because when it rains to the let's assume when it rains to the Ridhi Bandiala and Moragaswava area, then there is a flood in Chilau without rainfall in the Chilau. So we have done that study also in here, and for my discussion part I have mentioned that for the further development. Thank you.
Thank you.
Any other questions from the audience? Okay, thank you very much, Prabhuti. And I think you could have easily done a comparison of models when you have the data with you. So you could have done a complete comparison with different models, as earlier the questions raised from the earlier members. They said that trying out with basic RNN, maybe other multi-layer feed-forward neural network and probabilistic models. So you could have tried out it, and it could have been a wonderful research, right? Thank you very much, Prabhuti, and I wish you all the best. So let's go to the third presentation. The third paper or the third presentation of this session is real-time greenhouse environmental conditions optimization using neural network and image processing. So the paper presenter is Piyumi Wickramarachchi, and she's from Sri Lanka Institute of Information Technology, and she's currently reading for her information technology degree and currently a fourth year student, undergraduate. So I would like to invite Piyumi, and let's start Piyumi's presentation.
Hi all, I am Piyumi Wickramarachchi. Now I'm going to present on our research, real-time greenhouse environmental conditions optimization using neural network and image processing. Let's have an introduction to our research. Agricultural business is one of the biggest areas in world economy. With the growth of population, losing agricultural lands is the major issue in world food production. Therefore, controlled environment agricultural systems under vertical farming have been introduced with greenhouses. In today's advanced agriculture, optimization of the environmental conditions within the greenhouse environment is a key aim. Climate of a greenhouse can be mentioned as a complex and uncertain system. Since there is the ability to grow certain cultivations inside the greenhouses throughout the year, greenhouses perform a very important role in food supply. The productivity of a cultivation can be accelerated by controlling the environmental conditions within the greenhouses. Then the optimal environmental conditions can be provided to the cultivation to maximize the crop yield and to gain higher profits. Let's move on to the background of this research. Here I have selected important and latest references related to our research area. The research on wireless sensor network and deep learning for prediction greenhouse environments predicts environmental conditions for tomatoes in greenhouse environment. Humidity, temperature and carbon dioxide are predicted according to the stages of plant growth cycle. They have used wireless sensor networks and actuators in this work. The research on hydroponic greenhouse crop optimization presents a way how the internal conditions of the greenhouse should be changed based on the external environmental conditions. A continuous time linear model has been developed to calculate the inside temperature and humidity levels. The research on towards controlling climatic parameters under greenhouse estimates the internal temperature, relative humidity and carbon dioxide conditions of the greenhouse based on the external values of these three conditions. Here, they have used a control approach called model-free control. The research on a neural network dynamic model for temperature and relative humidity control under greenhouse can be mentioned as an enhanced version of this research. There, they have developed a dynamic model for estimating internal temperature and relative humidity of the greenhouse. External temperature, external relative humidity, and ventilation are the inputs for models, and then the optimal parameters given as the output. The research on greenhouse carbon dioxide control based on improved genetic algorithm and fuzzy neural network has aimed on controlling carbon dioxide level inside the greenhouse environment. Carbon dioxide is one of the main sources of photosynthesis of crops. Due to the closure of the greenhouse environment, carbon dioxide concentration indoor will be much lower than outdoor without new carbon dioxide injection. Therefore, a neural network control algorithm based on structure and parameters of improved genetic algorithm training is proposed from this research. Considering on the research background, we have identified that there is no way to gain a feedback of plant growth continuously, and based on that, there is no way to predict optimal environmental conditions to gain a target plant height. Let's move on to the methodology of this research. In the methodology, I am going to explain on these sections: data collection, pre-processing of input data, condition prediction algorithm, post-processing of output data. Firstly, let's look at on data collection. Data collection has been done using tomato plants. The used species of tomato is Lanka sour, and plant samples of Lanka sour were cultivated according to the hydroponics cultivation technique. There, the Albert's fertilizer mixture was used as the fertilizer. The pH value of nutrition solution was maintained between 5.8 and 6.8. Here we have assumed that the nutrients given by the sunlight are provided by the growing light, and the plants in samples are free from the diseases that can be affect on the plant growth. In data collection, we have to prepare three data sets: carbon dioxide data set, temperature data set, and relative humidity data set. When preparing carbon dioxide data set, carbon dioxide level should be changed from 450 to 950 ppm. There, the temperature and relative humidity levels should be maintained in the standard levels that are suitable for greenhouse tomato growing. When preparing the temperature data set, temperature level should be changed from 21 to 26 degrees of Celsius. There, the carbon dioxide and relative humidity levels should be maintained in the standard levels that are suitable for greenhouse tomato growing. When preparing the relative humidity data set, relative humidity level should be changed from 50 to 100. There, the carbon dioxide and temperature levels should be maintained in the standard levels that are suitable for greenhouse tomato growing. Now let's see how to prepare the data set for carbon dioxide. When preparing the carbon dioxide data set, we used 3 samples of plants. At the beginning, each sample was provided the carbon dioxide level as 450 ppm. Temperature and relative humidity levels were provided in standard levels that are relative humidity is 70% and temperature in 24 degrees of Celsius. On the day 1, parameters for plant growth were not taken because the plant growth is not visible. On the day 5, plant height is visible. Therefore, from the 5th day, plant height is measured, and an average plant height from each sample is taken. Likewise, the current height of the plants in each sample is gained day by day up to day 24. It means the plant height should be gained from day 5 to day 24. Then the separate data sets for carbon dioxide should be merged into one data set. By following this procedure, we have to prepare carbon dioxide data set by changing carbon dioxide level from 450 ppm to 950 ppm. Same as to the carbon dioxide data set, the temperature data set should be prepared by changing the temperature level from 21 degrees of Celsius to 26 degrees of Celsius and measuring the respective plant height. Same as to carbon dioxide and temperature data sets, the relative humidity data set should be prepared by changing the relative humidity level from 50 to 100% and measuring the respective plant height. By using the prepared 3 data sets, expected height for next 24 hours should be calculated by gaining the difference of 2 consecutive plant heights. We trained the carbon dioxide algorithm by gaining a 90% of input data randomly. Same as temperature and relative humidity algorithms were trained. These 3 algorithms are used at the application when gaining a target height of the plants. These are the 3 algorithms that we have trained. 3 algorithms have been used at the real-world application. There, 3 algorithms are having 3 inputs. In this application, there are 3 sections: pre-processing of input data, condition prediction algorithms, and post-processing of data. Now, let's have a look on pre-processing of input data. In pre-processing of input data, we prepare the inputs for 3 algorithms. There, firstly we have to select a target date and a target plant height. Here, the target plant height is 11.5 centimeters and the target date is 14. By analyzing the data sets, plant height values should be predefined to gain 11.5 centimeter height within 14 days. These are the predefined values to gain 11.5 centimeter plant within 14 days. This process happens from the first growing day. Let's assume that now we are at the beginning of 12th growing day. Here we consider the 12th record of this table. Growth rate of the plant is 12. Current height of the plant is the actual average height of the plants on 12th growing day. Current height of the plant is 8.19 centimeters, but the predetermined expected height on 12th day is 8.1 centimeters. Then the error is identified by comparing the current height of the plants and expected height. That error is 0.09. Predefined height for next 24 hours is 1.6 centimeters. But the new expected height for next 24 hours is 1.51. Now let's see how these three algorithms work. Here we have three condition prediction algorithms. It means we have trained three separate feed-forward neural networks. This is the architecture of a one neural network. It's having a one input layer, two hidden layers, and a one output layer. Considering on the condition prediction, each algorithm is provided three inputs. Since now we are at the beginning of the 12th growing day, three algorithms predict the conditions that should be provided over the 12th growing day. These are the predicted condition values. Then these values should be sent to the closed-loop control system. That process is explained by post-processing of output data. In this process, current environmental condition value in the control environment and the predicted condition value by the algorithm are compared and the error is calculated. Then the controlling device tries to minimize that error by providing the particular condition. This will take some time to balance the actual condition value and the predicted value. After balancing two conditions, error will be 0. And then the function of the controlling device will be stopped. Then this condition will be maintained within the control environment up to the beginning of 13th growing day. Now I'm going to explain the results of this research work. Let's consider the accuracy of the trained model. From the prepared dataset, 90% of input data were taken randomly to train the model. Remaining 10% of data taken for testing. Test results were compared with the actual results. Here it shows the actual targets and the predicted targets. R2 score is the method that can be used to illustrate the accuracy of feed-forward neural network. The R2 score for carbon dioxide prediction is 88%, and the R2 score for temperature prediction is 92%, and for relative humidity it's 89%. After training the algorithms, we have applied them into a real-world scenario. This real-world scenario is gaining 11.5 centimeter height plants within 14 days. Then we gain these condition prediction values for all 14 days as the result of integrated system. In the integrated system, plants are provided a combination of three predicted optimal values, but accuracy of the data sets were considered individually. Therefore, it was problematic what will be the final result when a combination of three predicted optimal values is provided to the plants. Therefore, we did few test trials according to this table. There, the first one is gaining 11.5 centimeter height plants within 14 days. But at the end of the day, the actual height of the plants was 13.43. Therefore, the deviation rate of the actual height from the target height is 16.8%. Same as these are the results of these test trials. Now let's move on to the conclusion of our research. A cost-effective, user-friendly environmental condition optimization method in greenhouses is presented by this research work. There, a regression-type feed-forward deep learning neural network has been developed. The performance of hydroponic systems in the greenhouses can be enhanced in an effective and efficient manner by this solution. The growth of the plants is checked for every 24 hours, and based on that growth, required conditions are provided to gain a target plant growth. Therefore, this environmental condition optimization is very cost effective, and the owner of the product can use this in an easy manner. As a future enhancement, this solution can be further developed to calculate the corresponding cost for resource consumption. These are the sum of selected important and latest references that we have used to our research work. Now I have come to the end of my presentation. Thank you.
Thank you, Pim. And now the stage is for questions. So now you can ask questions. Pim is ready.
Okay, Pumi, one question like, what is the overall accuracy of the model when you consider the one? Why do you consider that carbon dioxide at certain levels, and what was the rationale behind that consideration?
When it comes to the integration solution, we did 4 test trials for checking how the accuracy will be when the plant is provided for 3 optimal conditions. For the accuracy of the carbon dioxide, prediction, it's 80.
Excuse me. Do you keep your mobile phone closer to you?
Yes.
We are hearing a noise. Could you please keep it away?
Oh, sorry.
Yeah. Now I think it's clear, right? Yeah. You can answer. Yeah.
Sorry,
Yeah.
For the carbon dioxide prediction algorithm, the accuracy 88%, and for the relative humidity prediction algorithm, it's 92%, and for the temperature prediction, it's 89%. Likewise, we predicted, we gained the accuracy separately for 3 algorithms. Then comes to the integration solution. It was problematic. What will be the accuracy when a combination of 3 optimal conditions provided to the plants? Then that's why we did 4 test trials to test that. In that case, we predicted the conditions, and then there was a targeted height, and then after we measure the actual heights, then we got the deviation from those 2 values.
So the values you get, the deviation from those 2 values is okay. My question is like how different this is from the realistic thing. I know it's what you said is like 80%, 92%, and so on. But when you consider the 3 classifiers, how different is this?
Considering on 3 classified.
All the things that you have integrated.
Considering on that, actually, we didn't have much time to do the all the test trials. It means a lot of test trials. That's why we did 4 test trials. From that 4 test trials, we got that accuracy.
Okay.
Okay, Pimi, I have a question. So you know that you keep carbon dioxide level constant in certain experimental setup, right? While changing the other fertilizer or the humidity and other parameters, right? So, but you know that when the plant is growing, it will need more and more carbon dioxides, and the requirement levels would be different by day, right? So when there are more leaves, more buds, right? It will need more carbon dioxide levels, and if you keep carbon dioxide level constant throughout the period, it will negatively affect to the growth of the plant.
When data collection part, we did that. It means we maintained the carbon dioxide level from 450 to 950. Then by doing that, we gathered the data set.
Yes.
By doing that, then when considering on the considering on the data set, it was the condition versus the respect plant height. Then in that case, we gain an average height for the plants from plant samples. In that case, there can be the height of the plants that are abnormal. Then we remove those abnormal values. Then we took an average value of the plants.
No, my question was when you want to, you created 3 separate data sets, right? So for if you take an example, the relative humidity data set. So you want to change only the relative humidity and keep all the other parameters constant, right? Without changing, right?
Yes.
So by doing that, what you expect is you expect that humidity is only the changing factor, and you want to see how that humidity will affect to the growth, right?
Yes.
But when you keep, for an example, carbon dioxide constant, when the tree or the plant is growing day by day, it may need more carbon dioxide. And when you do not provide that the required level, when you keep that carbon dioxide level constant while changing the relative humidity, will it negatively impact to the growth of the plant by keeping carbon dioxide level constant? That's my question. I don't know. That's something I had doubt.
By maintaining the carbon dioxide level constantly and change and
so when in a separate setup you keep all the carbon dioxide and all the other parameters constant and change the relative humidity only, right? So by doing that, you expect is to see how relative humidity affect to the growth of the plant, right?
Yes, in that case, we used other 2 conditions as the normal greenhouse farmers used conditions for a greenhouse tomato farming. Therefore, we assume that then it will not affect that much for the growth of the plants.
Okay.
No, I have the same question. Like for example, like you have okay, you set carbon dioxide at 450 on day 1. So you run it for 24 days. So correct, right?
Yes.
So is 450 carbon dioxide is going to be there at the end of day 24?
Yes. From
How?
it means we provide the carbon dioxide as 450 ppm.
So you keep on injecting that into the system at constant levels for 24 days.
Yes.
All right. So and other parameters you assume is not affected by you injecting this into the system, is it?
Yes, we maintain that conditions as standard values. It means normal values suitable for most of the time.
Yeah, but I agree with the chair's question. Like for example, like when you grow older, you need more food to eat. So trees grow on the amount of carbon dioxide that you intake, right? So from the nascent age up until when you get to 24 days, you would need more and more and more. So wouldn't that be inversely affecting your data set you have created?
It means we do not plant we do not grow the plants up to it means that much height. We from day 1 we grow the seeds, and when it comes to day 5 only it has a visible plant height. Then considering on the 24th day, it may not have a considerable height. Therefore,
so height is height proportional to the amount of carbon dioxide you intake?
It means from day 1 to day 24, we use a constant value of carbon dioxide.
But if leaves get bigger and bigger, so it needs more carbon dioxide, no?
Yes, that's why we used samples of plants to check that. Then another sample used for 550 ppm. Likewise, we changed the provided carbon dioxide levels.
No, actually, the question is the captured data and the way that you captured the data. The question is whether it has a bias or not, right? I mean, I'm not sure. That's why I asked the question whether it has a bias sort of thing. When you capture when you change the carbon dioxide level, you are keeping the relative humidity constant, right? Will that, I mean, keeping relative humidity constant, will that affect negatively? So that's a doubt I had.
In that case, when collecting data, we assume that it did not have that much effect for the plants.
So if that affects, basically your data set is skewed in that case.
Sorry?
Because if that particular thing actually affects the data set or the outcome, whether when you're considering it as constant, the findings is basically biased on certain cases.
Sorry, it means? Sorry?
So what I meant was like if the other affecting of when you are keeping certain things constant, and it might affect the overall growth of the thing, and because of that thing it might negatively affect the eventual data you are collecting. And when you are having the data which is affected by external things that we actually do not know, the findings of your classifier might not be very accurate.
And one other question that I had, you said that in your neural network you used 4 hidden layers sort of thing, right?
2 hidden layers.
2 hidden layers. So on what basis you decided that I'm going to use 4 hidden layers? Why not 3? So what is the what sort of thinking behind that decision? What is the rationale?
Because this is some kind of regression type problem.
Okay.
We thought that we have to predict the optimal conditions. Therefore, we did that. We chose that.
I think you could have tried several experimental setups for that as well. I don't know whether it is possible. Straight away, if you say I used 2 hidden layers, that looks a sudden decision, right? So, right. Any other questions from the audience? Okay, it seems there are no questions. Thank you very much, Piyumi. I would like to wish you all the best in future studies and future research. Thank you very much.
Thank you,
and our final paper in this session, there were 4 papers, and the final paper is forecasting better price for trip packages based on historical sales data and related factors in the context of Europe railway tourism. The paper has several authors. Seems there are 4 authors. Yes, and today the paper is presented by Kavinda Atapattu. And Kavinda Atapattu graduated from University of Colombo School of Computing, and he is having Bachelor of Science honors in Information Systems program. And currently he works as an assistant lecturer in the Department of Information Systems Engineering at University of Colombo School of Computing. His research interests are machine learning, augmented reality, and virtual reality. So I would like to invite Kavinda, and I think first the presentation will be played, and then Kavinda will be here to answer your questions.
Hello everyone. Title of our paper is Forecasting Better Prices for Trip Packages Based on Historical Sales Data and Related Factors in the Context of Europe Railway Tourism. Authors are A.M.K.B. Atapattu, E.H. Guerrero, S.M. Pereira, M.G.N.S. Fernando from University of Colombo School of Computing. This is the overview of our presentation. Introduction. Dataset was acquired from Visit Flam company, which is a railway-based tourism company located in Flam, Norway. So this is our research design and methodology. We have divided it into 3 phases for ease of explanation. In phase 1, background research, determine research problem, scope, goals and objectives, literature review, acquiring historic data and acquiring external data set, and data pre-processing was included. In background research, Visit Flam has online trip booking and reservation. They provide wide range of packages of tours, and they have electric locomotives, and they have 9 departure locations. We did a background research to gain high-level understanding of the problem domain. Topics covered the recommender systems, business intelligence, price forecasting, and railway tourism. Research problem. Visit Flam currently uses manual trip pricing, so they sometimes do not achieve good revenue. In Europe, there are rapid weather and seasonal changes. Therefore, we have to consider these when predicting prices. So, research questions. Number 1, what are the current techniques for pattern recognition, business intelligence, and forecasting better prices? Number 2, what are the gaps in the current techniques described in research question number 1 with respect to forecasting better prices based on sales patterns, considering related factors in Europe railway tourism? How to propose a better price model for forecast price based on sales patterns to the Europe railway tourism to overcome gaps in research question 2 by considering the factors. Scope. Prediction was based on the dataset provided. Data recorded only several locations for 1890 packages. Only trips period were considered, not the trade was considered trip price. Up weather, holiday and season. Only for destination from current solution to forecast a better price and to answer the first 2 research questions. So for research questions 1, we found that extreme learning machine, support vector machine, artificial neural networks, Sarimax model and linear regression are the current mostly used techniques. And what are the gaps in the current techniques? Overtuning and log computational time. These may fail when the data is not seasonal or cyclical. Overfitting and curse of dimensionality was identified. Data gathering. We acquired historic data set from the client. It contains 60 tables and we identified 6 between tables. Seasonal data, we gathered seasonal, weather and holiday data. Weather and seasonal data was data processing. First, we select table and only distinct strips for these packages. Only the necessary fields were taken. Then the external tables, weather, season and holiday was joined to the dataset to create the full dataset. In the phase 2, with the implementation, we implemented several models, including deep learning model, support vector regression, extreme learning machine, ordinary least square, multiple linear regression, and Sarimax model. So this is the implementation of deep learning model and the structure of the neural network. And we implemented support vector regression in RBF model, linear model, and polynomial model. So you can see the predictions of each model with high amount of data, moderate amount of data, and low amount of data. So extreme learning machine was implemented using a single hidden layer feed forward neural network, and it predicted the price class, not the exact price. So ordinary least square multiple linear regression was implemented using sklearn library and stats model library. In sklearn model library, so we split the dataset into 20 to 80 ratio for testing and training. In stats models library adds constant which will make the line fitting much better. So we also received a model summary for these models. So in the Sarimax model, the chosen time series model was Sarimax because we need to consider seasonal and trend details. We implemented it using Matplotlib, Pandas, NumPy, and Seaborn. So Sarima with exogenous variables is known as Sarimax. The exogenous variables we used are weather, season, and holiday. So, but the Sarimax model cannot be used for forecasting future dates if the data is not continuous. So, comparison and model creation. In the phase 3, we first compared the results of each model using root mean square error. Model with the least root mean square error was considered as the best model for that package. So in literature review, we discovered several models. After testing, we reduced the viable number to deep neural networks, ordinary least square multiple regression using stats model and Sarimax model. After further testing, we selected deep neural network and ordinary least square multiple regression using stats model. So creation of the hybrid model. The hybrid model was created using deep neural network, ordinary least square linear regression model, linear interpolation function, and a maximizing function. So this is the overview of the hybrid model. So in first step, data was input from the UI to the hybrid model. Data received a package number and the departure date. So then we retrieved the data from API and extracted the required data. Extracted data season, average temperature, sun hour, total snowfall, and UV index. So then we checked whether the all the data from APIs are available and whether we can calculate a better price for that trip package. So for example, if that package does not have more than 2 data points, we cannot calculate a better price. So then we selected the model which will give the best price prediction for that package. The models are DNN and OLS multiple regression. So predicting the price. So we then predicted the price using the external data. This price represents the price that will Flam Railway will manually assign to that trip. So then we had a sub process to calculate the better price. So then we output the calculated better price using previous sub process. So the interpolation function. So we use linear interpolation and it uses deflated price versus sales data. So why did we use an linear interpolation function? So as you can see, it's the one with the least average error for each package. So you can see the best model here is the linear model. So calculating better price sub-process. So this is the flowchart of that sub-process. So first we input the price predicted in the previous step. So we consider this as the manually calculated price. Then we adjust it for inflation because interpolation function uses prices adjusted for year 2018. So why did we choose year 2018? Because that's the latest year with the data. So then we check whether the data is within the interpolation function because we are not extrapolating because with the small number of data, extrapolation will increase the error significantly. So then we use that function to get the number of sales for the price. So here we can see that for price 49.5 sales volume is 1225.73. Then we increase the price by 0.5 and try to find a better price within the range which will give a better revenue than the input price. So why didn't we check lower prices than the predicted price? That's because we were not able to get the cost of each package. Therefore, if we go for a lower price, we might incur losses instead of profit. So here we can see at the price 50, we can get sales 1,804.78. So which will give a better revenue. So then we adjusted this better price for the required year. So we deflated price from year 2018 to the required year. So results and the evaluation. Root mean square error, mean absolute error, and mean absolute percentage error for each model was recorded. But for extreme learning machine, accuracy of prediction was recorded. Discussion. In this study, we have compared and constructed 6 models of forecasting, but in literature, we found that they have compared at most 3 models. Sarimax model was the model with the least mean square error, but it was not suitable for the prediction of future prices because it involves significant amount of assumptions. And we have strived to obtain a better result by creating a hybrid model. So best price was predicted for 75 packages using DNN, and for 3 packages ordinary least square linear regression was used, and 11 packages had too little data to get an estimation. So what do you mean by too little data? So here you can see package 37 has only 1 data point and package 16 has only 2 data points. So we cannot find a better price. So estimated theoretical revenue increase was as follows: a maximum of 120.59%, minimum of 12.12%, and average of 79.25%. So for future work, we can train the model using more external factors. We can include the cost of each package to improve calculating better prices. And we can implement and evaluate other methods of price prediction like game theory. So we can evaluate the change of demand with predicted price considering real customers. So these are the references we have used. Thank you.
Okay, Kavinda, thank you very much. So shall we move to Q&A session? Yes, Kavinda is ready. So audience, all the members in the audience, please let us know your questions. I can see there are lots of attendees for this session, so I think it would be real nice to see have your questions or opinions, maybe to improve Kavinda's work. Yes, I can see that Dr. Buddy is raising his hand. Yes, please let us know your.
Hello, Kavinda, it's Buddy. I was wondering the benefits of this research in terms of use in predicting the sort of price of packages. Is it more beneficial for the supplier of the package or the consumer of the package? And if
so we are focusing mainly on the supplier, that means the company, so they can generate more revenue using this model.
Would it be useful to look at the consumer as well, possibly using sort of similar data so that the consumer gets a better deal as well, in which case the producer gets a good business? It's a two-way solution.
Yes, sir. So we have to choose who will benefit. So customer will like to have the trip at zero cost, right? So and the company will like to have the trip at the maximum cost they can, maximum price they can sell it. So we have to balance it between these two, using there should be a balance and balance in demand and supply. So I think we can use this and try to test this on real platform to get an idea how this will affect customers as well.
Yeah, I think what you need to consider is what best price is for the consumer. And it's not necessarily zero cost. It is the best price is usually the best value, the what I get for what I pay. And the in terms of the seller, it is what I have to spend to provide what I provide. So those two things can be you can match them perfectly, but those are two different areas which might benefit in future, in future work from your research.
Yes, sir, I agree.
Thank you.
Thank you, sir.
Any other questions or opinions?
So you have used so many machine learning models, right, for do so many things. So when you consider the standard error of prediction in this system, do you think it is within an admissible range, or is it like not computed as it now?
So the problem was we had so much data, so we tried to minimize the error. So this is the best we could do with the time frame, and so we can improve it further in future works.
No, my question was like, is the errors exacerbated by model on top of a model on top of a model kind of a scenario?
No, sir. Actually, so when using these models, they were compared individually. So the errors do not adapt to each other.
Okay, so my perspective is like basically, yeah, it's good to have the modeling done by multiple models and with different reasons, and also you have estimated using an linear estimators and so on. But you also need to have a certain rationale for using that, and just because it fits the dots nicely doesn't mean it's always accurate. So that is a thing that I need to say when I looked at your graph. That is what I saw. So just because it fits the dots, it doesn't mean it has any rationale. So that's why I asked the question. Okay, thanks.
Okay, any other questions? Okay, Kavinda, I saw something like in your slides. That's a simple comment, not a question. It's like I don't think we can go back to the slides because it was a video that we played. Anyway, there was a research questions, and in there were several research questions, and your first research question was like a generic research question. What is the best way to forecast something?
Yes.
So I think in order to answer that sort of question, this study looks insufficient. So you should do a broader study, like with more data sets, different data sets. It was like a generic research question. What is the most suitable forecasting model or something? That's what I can remember.
Sir, in the first research question, so we tried to find out what are the techniques that are used in the price prediction in the literature. So those are some of the techniques we found on the price prediction topic.
Okay, I mean, if you are going back to literature and search and read things, I think that's not a sort of a research question, right? So you just refer the literature and doing survey. and review, right? It's a comment, right? So I'm going back to the audience. If you have questions. Now it's 65 attendees, and Dr. Buddy is raising hand again.
Yeah, Kavinda, I was thinking that with the COVID-19 sort of effect of affecting all of the tourism and holiday packages, you might want to consider other factors as well in your future research to extend this research on how the tourism industry can recover on adjusting the best pricing in the future. And for Sri Lanka, it will be very useful as well if you can develop this in a way. And like I said before, I'd like to see the consumer also considered separately, obviously, but it's a way that the consumer gets the best value and the producer gets the best value as well. So it's a good research project which you can, I think, extend for a post-COVID-19 environment all over the world.
Yeah. Yes,
Thank
sir.
you.
Thank you, sir.
Any more questions? Okay, then let's conclude this session. And thank you very much, Kavinda, and I would like to wish you the best in future endeavors. Thank you very much. And over to you, Kulani. Kulani, your mic is muted, so we can't hear you.
Thank you, Dr. Gunawardhan and the authors who presented. I request all the attendees to wait a few minutes for the other participants to join this session for the closing ceremony.
Hi everyone. We've had an interesting technical paper session. So I'm happy to say that we have successfully completed the proceedings of the main conference. The keynote speeches that we had, a paper and poster presentations were quite interesting and informative. So ICTer 2020 has utilized the expert opinions of a panel of 5 judges to review the research papers in order to select a paper to be presented the award for the best. This has not been an easy task at all because all the papers were of good quality. With much effort, the panel has been able to select an outstanding publication for the ICTer 2020. To talk about this, I'd like to invite Senior Professor Nihal Kodikara, Publication Chair of ICTer 2020.
Thank you very much. Yes, this year, of course, there were very good papers throughout, and to select the best papers was not that easy. But there was a committee, and they looked at various aspects like paper quality and the reviewers' comments as well, and also their presentations. So the committee members attended the presentations as well, and they had a difficult task of selecting best papers this year. because most of the papers are good and I've used good latest technology and research methods as well. So they finally came up with a short list of 9 papers. And then to select the best paper was also not that easy. But finally, after a lot of discussions, they have selected 2 papers this time as the best paper. So there are 2 papers selected as the best papers. And there are other 7 papers also there. So they were also recognized as good quality, excellent papers. They also will receive certificates. And the first 2 the best papers are these 2 papers. First one is paper title. I'll say the paper title first. Dimensionality reduction for cluster identification in metagenomics using autoencoders. Authors are Udita Maduranga, Kalana Vijayagunaratna, Sadeepa Veerasinghe, and Indika Pereira, and Anuradha Vikramarachchi. And the other paper, of course, is paper title again, usage of combinational acoustic model, DNN, HMM, and SGMM, and identifying the impact of language models in Sinhala speech recognition. Authors are Buddhi Gamage, Randil Pushpananda, Ruwan Veerasinghe, and Tilini Nadun Godage. So they are the 2 best papers this time were selected. And let me read out the other excellent papers as well. Okay. There are 7 other papers. They also will receive certificates for excellent papers. First one is paper title, Simplified Approach for Predicting Emotions of Multi-Turn Textual Awareness. Authors are Jasigan Vikneswaran, Pirthik Pirunath Veeravansan, and Vihasan Vijayaratnam, and Uttaya Shankar Tyartiseva. And then the second one, of course, paper title, The Use of Conversational Interfaces in Long-Term Patient Care. Authors are LASM Gunatilaka, WAUS Veerasinghe, IN Vikramasinghe, V. Velgama, and AR Veerasinghe. And the third paper title, Sinhala and English Document Alignment Using Statistical Machine Translation. Authors are Rajita MDC, Priyanta LLC, Nayanajit MMDS, Surangika S. And the fourth paper, Swarmform, a distributed workflow management system with task clustering. Authors are Ayesh Veerasinghe, Kalana Vijayatunga, Randika Jayasekara, Indika Pereira, Anuradha Vikramarachchi. And the fifth paper title, CNN, RNN, LSTM based hybrid approach to detect state-of-the-art stance-based fake news on social media. Authors are Gunatilaka, MDPP, Kumar, PPNV. And the sixth one, paper title, Machine Learning Approach for the Detection of Hate Speeches in Sinhala Unicode Text. Authors are SWAMD Samarasinghe, RGN Meegama, and M. Punchimudianselage. And the seventh one, the last one, paper title, Priority Based Subflow Selection of MPT CP, a Case Study. Authors are Krishant Liyanage, Tarindu Vijayatilaka, Kasun Gunawardana, Kenneth Tilakaratna, Premal Vijayasekara, and Chamath Kapetiago. So these are the 7 excellent papers. So the earlier ones are the best papers of the ICTer 2020 conference. So I congratulate them for this achievement. Thank you.
Thank you very much, Professor. Congratulations to the authors who won the Best Paper and the Excellent Paper Awards of ICTer 2020. I'm sure your sleepless nights, hard work and perseverance has finally paid off. So this indeed is a moment to cherish, and I'd like to add our warmest wishes to you. On that note, I'd like to invite Professor K.P. Heragamage, the Director of UCSC, to deliver a note of appreciation.
Hello, I hope you can hear me. Am I correct, Dishani?
Yes.
Yeah, okay.
Yes.
Very good evening to all of you. I think I'm not going to talk a long speech. This is at the end, and especially I wanted to thank all the people who have contributed to make it happen with all these difficulties during the last few months. Well, when we started to plan the ICTer conference, it was almost 1 year ago. We never expected this sort of a situation. We were planning to have another conference like the last year, but somewhere in the middle, we decided to move to a blended format. So I initially thought that's a very good way where we can open for the other people, but finally we decided to move to the online mode only. I hope there will be both sides, good and bad. And this is a kind of a new experience to all of us organizing something like that, also participating. So many challenges we faced. And I like to invite all the participants to provide your feedback by filling the form or sending your comments to the conference organizers. Then I also wanted to say, I think this is a ICTer conference, even though the UCSC is organized, as I mentioned. We have a lot of collaboration and cooperation with the other academics in the other universities. And this is not a conference where we present one organization papers. This is from the all. This is IEEE conference, and the IEEE community plays a very important role here. So your future cooperations, we highly appreciate, and we will invite especially the academics from the other universities, as well as the industry representatives, and their support is also helped a lot in the past as well as in the future. We hope your support to make the conference moving forward. And at the same time, especially wanted to thank the conference co-chairs as well as the team behind them. Especially this is a kind of a small project which was started almost 1 year ago. Where this year it was very challenging. So although we planned it in one way, finally we had to do it in a completely different way. However, we wanted to maintain the quality, and there were some suggestions to postpone this one or cancel the conference, but I didn't want to do that one because the people submitted the papers. We have a responsibility to conduct and give due credit for all the authors who submitted. And then there are lots more work to do it in the coming weeks to finalize it and send these papers to the IEEE to include it, because the process is not an easy thing. There are several evaluations they do it before they include in the IEEE Explorer digital library. So that's our responsibility. We will do it. And well, to do this work, so even though today is the last day and conference is coming to the end, but the organizers will have to do some more work during the next few days. And especially I wanted to highlight the contribution of the Dr. Sridharan and Dr. Kasun Karunanayake, who accept our invitation on behalf of the main organizing committee to take the leadership, and the support given by the academic, senior, junior, UCSC, as well as the other universities, by contributing in different ways, including the paper review and all these work. That was not an easy job. I think people who have done the organizing the conference may know this is much more harder than publishing the paper, and but it's a real good experience, and everyone should try that one because that will give a good opportunity to learn, and also how to promote the knowledge dissemination, which is not an easy thing. Well, when you want to get the work from the other people, and especially the core group, which are the core group with the two co-chairs, both the junior and senior staff members, as well as all the people who supported. Once again, I wanted to thank them, and hope we will have a better year next year, to have it at least in a blended format. So that's my hope. And if the things comes down to the normal situation, but whatever the things, ICTer will happen. That's what I want to say. And we'll invite the others to join in the next year and keep going. And thank you very much, and have a nice weekend. And hand it over to the organizers. Thank you very much.
Thank you, Professor. Please note that the extended versions of the papers that won the Best Paper and the Excellent Paper Awards are invited to be published in the ICTer journal. So we are getting close to the end of the conference, and to deliver the final remarks, I'd like to invite Dr. T. Sridharan, co-chairperson of ICTer 2020.
Thank you, Tushani. Good evening, ladies and gentlemen. As one of the co-chairs of this conference, I am pleased to speak to you at the conclusion of the 20th International Conference on Advances in ICT for Emerging Regions, conducted by the University of Colombo School of Computing, Sri Lanka. So due to the prevailing situation all over the world, owing to the COVID-19 pandemic, for the first time in the history of the last 2 decades, we have to conduct the conference completely as a virtual conference. We would very much appreciate all the academic, administrative, and non-academic staff members of the conference organizing committees for the immense contribution given throughout this year. I hope that the experience that we gained through this conference will definitely help us to improve the standard of various oncoming conferences that may be held via the virtual mode. We would like to congratulate the shared Best Paper winners, Excellent Paper certificate receivers, and all other authors who have presented papers in this year ICTer 2020 conference. Further, we would like to invite you all to be part of the ICTer 2021 conference, which will happen next year. I hope that you all had a pleasant and memorable conference. Further, I hope that you all would have shared as well as taken back with you the knowledge that would further research in the domain of ICT. I do not want to take much of your valuable time. I now declare the 20th International Conference on Advances in ICT for Emerging Regions closed. Have a great evening. Thank you.